just need to be able to break it down. That's what we're going to get today. Any questions about that? So let's do 17. Is 36 a perfect square? Was it on the list yesterday? Is 49 a perfect square? Was it on the list yesterday? So can I factor this? You just take this person's up perfect squares. What is the square root of 36? If you didn't know that, use your calculator to find that. What is the square root of 49? 1 with a plus, 1 with a minus. Very little thought has to go into that as soon as you recognize that it is a huh? How you factor different squares. No, the other one is the harder part. The trinomials with the focus. I thought we could throw this in on it. But this is really not a full day's lesson. Okay, let's look at the next one. Currently, is the next one a difference of perfect squares? No. Does it have a GCF? What is the GCF? 3x? How is it a difference of perfect squares? So don't forget, try GCF first. Always try that first. The square root of 9 is 3, and the square root of 4 is 2. 1 with a plus. Again, how do you recognize a difference of perfect squares? How do you know that that's what we're going to do to it? We can figure that out. This is easy. Okay, there's two terms. They're both perfect squares. And there's a subtraction in the middle. So we have two numbers, perfect squares, subtraction in the middle. We can always is 16 a perfect square? Is x to the 4th a perfect square? Anything with an even exponent will be a perfect square. And is 1 a perfect square? 4x squared plus 1 and 4x squared minus 1. Any questions so far? Questions so far? Do what? What do you mean simple? Is there another difference of perfect squares? Squared. 4x squared and 1? Are those both perfect squares? Is there a subtraction in it? Is this one a difference of perfect squares? Why not? So this one I can't do anything with it. I'm going to leave it alone. It doesn't factor that way. And the reason it wouldn't is because, no, this one has a 4, but say it just had a 1. What are the factors of 1 that add to give you 0? You see how that's never going to work? Where to subtract, we can make that 0 happen. So I'm going to factor the second one in because I can. It did say factor completely. That's how I know I need to do that one more time. Okay, so what are the factors of 4x squared? What's 2x and 2x? 1 and 1 plus and minus. So that is completely factored. That one was a little tough because we had to do it twice. If you have a 4th power, look for that. The only way that would happen is if you have a 4th power, otherwise your x's would be able to. The last one's just really Is 64 a perfect square? Is x squared a perfect square? So why is the 4th perfect square? Is 256 a perfect square.
Yes.
It is, isn't it? What's the square root of 256? It's 9 a perfect square. So, I can do this. Does that make sense? How do they check to see if 256 was a perfect square? Square root it in your calculator. So if it gets to be a number bigger than our list, just plug it in the calculator to see if it's a perfect square. So the square root of 256 over 9 is 16 over 3. I just square rooted the top and the bottom. And one gets plus, one gets minus. So that one is as nasty of a perfect square problem as I can make. And it still wasn't too terrible. Especially with a calculator. Without a calculator. Good so far? The second goal for the day is to learn how to factor trinomials with a leading coefficient other than 1. If you have a way that works for you, I want you to use it. I'd rather you not change how you do things, but we all came from different places, and so I'm going to teach it probably different than you've learned before. I don't know. I thought about it last night, and I decided that'd be good because if you didn't get it a different way, you might want to see it anyway. If you already know how to do it, then you don't need me at all. You already know how to do it. So that's wonderful, and you can do it your way. So that was kind of my thought process. So I'm going to go through the same thought process I went through yesterday. Why is it a little tougher today? There's a number in front. So now when I do the inner and outer terms, I've got a number in front and in the back, and so that makes life a little harder. But the thought process is the same. What are the factors of 9? What could be our numbers in the front? 3 and 3, and 1 and 9. What are our factors at the end? Now, normally we don't do anything else with this, but I do want to make sure that I cover all my bases and check both ways. So I'm going to take one of the two lists and write it both ways so that I check all possible combinations. So I'm going to take this list over here and rearrange it. You can rearrange either side, but you don't have to rearrange both. So I'm going to write 9 times 1 also. Do I need to write 3 times 3 again? The way I do it is I guess and check, but systematically, instead of just randomly guessing and checking. We're going to go through and guess and check. I know these are the things that could go in the first part of the parenthesis, right? With the x, right? It's either 9 and 1, 1 and 9, 3 or 3. And these are the things that could go in the back of the parentheses, right? So I'm going to multiply the inner terms and the outer terms and see which ones add to give me 18. So the thought process is the same as yesterday, except that I've got a little more work to get there. So I'm going to multiply the inner and multiply the outer and see which ones add to give me 18. So on the first numbers, I'm multiplying the 3 and the 2. Everybody see that? What is 3 times 2? 6. And then I'm going to multiply the 3 times the 4. What is 3 times 4? So I get 6 and 12. Those add to give me 18. Y'all picked a really good combination the first time. Sometimes it works. So I'm going to multiply the bigger 2, these two together, and then the outer 2. And then I'm going to see which ones add to me 18. There we go. Okay. Those worked. Once I see which ones work, I'm going to start. This is very similar to the Korean method. The difference is the way I stack them. Does that look familiar to y'all? Stack them a little different. something completely different. So, and I have no idea what you learned. Any questions so far? Where does the 3 and 3 go? So I picked it and I said it worked. Where does it go? In front of the X. Why does it go in front of the X? Because it came from the 9, right? So a lot of times that's people's question with gradient method, with any method, is how do you know which one goes where? Well, if you're thinking logically about it, that has to go in front of the X because it came from the 9. And then what about the 2 and 4? Where do those go? From the 8, right? If you put them down in the order that you circled them in, they'll be in the correct order for FOIL. Because we checked the inner and outer there. Because we had a plus, we have the same sign, and what are both of the signs? Would you agree this was tough? What should we do? Yes, before that. Check it. What do I mean check it? FOIL. Is 3x times 3x, is that 9x squared? Is 3x times 4, that's 12x, right? Plus 2 times 3x, that's 6x. It's 12 plus 6x, 18x. And 2 times 4 is that 8. What if you messed up? Well, I can fix it, right? Just try again. Let's look at this one. Again, if you have another way that you already know how to do this, use it. You do not have to do it my way. The best way to do it is the way you know how. Any questions so far? So what am I going to list before I ever start? A multiply to give me 20 and a multiply to give me 6. No matter what method you use, does everyone have to do that in their method? Have to figure out what multiplies. Did anyone learn slide and divide? It's just completely different. You did. You don't remember though. Every other method kind of mirrors this. Slide and divide is kind of Any questions about that? And then this list is 1 and 6 and 2 and 3. One of the two lists I have to write both ways. If you want to always write the first list both ways, that's great with me. I'm a shortcut taker if possible, aren't we all? I would pick the shorter list to write it both ways. You know what I mean by that? But you don't have to. But that's what I would do. I would pick the shorter list and write it together. This time, instead of adding, I'm subtracting to get 7. So I'm looking for those inner and outer terms to subtract to get 7. I'm going to go slow through this. I'm going to multiply the inner terms together and the outer terms together. And I'm going to write them over here at the side. You probably won't ever do that. Just like last night, you probably didn't write all the factors down, and that's okay. So I have 20 and 6. Everyone know where the 20 and the 6 came from? 20 times 1 and 6 times 1. Do those subtract to give you 7? No, move on. You can go through the list however you want. I would be systematic about it. I would probably try the 20 and 1 with all of these, and then try the 2 and 10 with all of these, and then try the 4 and 5 with all of these. As you get better, you will learn which one to try first. Do you know what I mean by that? Right now, we're just trying them all. Just because we don't know what to do, we're new at it. So I want you to see me try them all. So if I went to the next one, 20 times 2 is 40. And 3. 60 and 2. And 120 and 1. How many of you knew just by looking that the 20 was probably not going to be the one to pick. Okay, so if you can see that, skip this list. Do you know what I mean by that? None of those pairs subtracted to give me 7. But we tried it. Move on to the 2 to 10. 10 and 12. These look a little better, don't they? 10 and 12, those subtract to give you 2, but they're closer than the others were. 30 and 4. 60 and 1. Okay. Let's skip it. 20. Oh, yeah. 20 and 6. And 60 and 1. Did any of those work? Move on. Of course, the last one. Well, sometimes it will be the last one. We got the first track. So. 4 and 5. 5 and 24. Does 5 and 24 subtract 87? 10 and 12. 15 and 8. Yes. 3 times 5 is 15. 2 times 4 is 8. That one worked. Took me a long time to get there on this one. Now this one was a harder one anyway because 20 had a lot of factors. A lot of them will only have a couple of sets of factors. It was a little longer. Where did the 4 and 5 go? Because where did they come from? They go with the x because they came from the x, right? 4x and 5x. Right? And 3 and 2. And those are the order I'm going to put them down in. Any questions so far? If you do it this way, as long as you leave it in that order, they'll be the right order. Good. Why is one positive and one negative? Same principle from yesterday, right? If we have a negative at the end, we're going to have 2 different signs, right? So one of them's plus, one of them's minus. Remember it was 15 and 8. So do I want the 15 to be positive or negative or the 8 to be positive? Which one? To get a positive 7. 8 to be negative? So that means the 2 would have to be negative. I encourage you to use guess and check on the signs. Try it. If you don't know how to put them down, try it. If you get negative 7 instead of positive 7, switch. That makes sense. How we doing? Okay. Feel good about it? It is definitely tougher than yesterday. No argument about it. Everyone would agree this is tougher than yesterday. That's why there's 100 different ways to teach it. ways. On this one, it really does not matter which one you pick. They're the exact same list. You only have to correct one of them both ways. Any questions so far? I'm adding to get 25. Are y'all okay if I don't write the combinations yet and I just multiply? So we're going to multiply inner and outer just like we would when we FOIL. And at first when I get 12 and 12, then I get 24 and 6. Stopping when I get there. 36 and 4. Cut it out. 6 and 24. 12 and 12. That's close but not there. 18 and 8. So far so good. None of those add to 25, do they? 4 and 36. 8 and 18. 12 and 12. Note so far on the blue list. See why you have to write it both ways? Blue list and good anywhere. 1 and 144. 2 and really big number. Is that okay with me? 3 and 48. None of those work. 2 and a really big number. 4 and 36. 6 and 24. None of those work. 3 and a really big number. 6 and 24. 9 and 16. 9 and 16. Now, again, I'm pretending I know nothing and I'm not doing any skipping. But you could probably, if you wanted to start with the 3 and 4 instead of the 1 and 12, you could. So just keep that in mind. It doesn't matter. Next part. So you see that you definitely need both lists, though, both directions to check the numbers. 4y and 3y and 3 and 4. Remember, the green ones go in front. I'm actually going to make those blue so you see that. And the blue ones go in front. And what are the signs? Both ones. Let's check. 9y plus 16y. Does that give me 25y? Yeah. And 4 times 3 is 12, and 3 times 4 is 12. See if you can start the next one. See if you can do this. one. 3, 10, 18, and 21. That's the only one you're going to require on that paper. If you feel like you need practice with different squares, a few more. I feel like you don't. Is that right? Just a few of those probably good. On the other paper, do the seems skip numbers. So do the evens. Do the evens on the trinomial. So that's 13 problems. That's not too bad, right? We can do 13. Okay. On the trinomials one, if you need to do more to practice, you have all 18 up in there. This one is a hard skill, so if you need practice with it, let me know. It is the hardest factoring technique. But you probably remember that from last year. Do you remember that from last year, this one being a hard one? When they came up, you got it. You used to. Okay, we ready to do this one? Do we feel like we got it? And it's okay if it took you a minute. Do we feel like we got it though? What did we do? You won't have to do 100 of these on your test. You don't have to be real fast at these. You know what I mean? You just have to be able to do. What do we do first? List the factors. And I think even with Korean method, you're going to do kind of the same thing at that moment. You write them down a little differently, but you do the same. And take one of the two lists and flip it. If you accidentally put both lists, it's okay. You just check the same thing twice. Okay, we're going to check inner and outer. And what are we trying to think about doing? When we multiply inner and outer? Subtract to get 13, right? So see how that works? Subtract to get 13. So what do we get? So we go to the whole list. We get 1 and 6. And 5 and 3. So 18 and 5, right? So it would have been on our first set of checking. Everyone agree? Inside I get 18, outside I get 5, and 18 minus 5 is 13. Good. So, what do I do with that? Where did the 1 and the 6 go? At the beginning with the x. Why do they go at the beginning with the x? They were from the beginning. And where's the 3 and the 5 go? At the end. Perfect. So, say we have no idea. What do you do? Okay. I have no idea. I don't know. So just put it down. 1 plus 1 minus. Right. So if this is hard for you, just put something down, and then we'll check. I get positive 18 and negative 5. Is that the right way? Plus 18 minus 5. Good. Yes. Now what if I got 5 being, what if I got this? 50-50 chance, try one way, but then work the other. Sometimes that's the easiest option. Just put it down and then switch it. Does that make sense? Any questions? So FOIL it and check. We have time to do another one. Do you want to see another one or do you want to work? Do you want to work? Do you want to just try some on your own and ask me questions? So you got about 10 minutes left in class, so don't. The one rule is that you actually work and ask me questions. You don't just sit there. And so if you're working and asking questions, I'll stop talking and let you think and ask questions. One thing just to be aware of, don't forget to check for a greatest common factor, because if there is one, would it make your life easier? Make the numbers much smaller. So check, and that is what I think that's what's on my next You see this 18, 78, and 60? How many of y'all want to write out the factors for 18 and 60? Me neither, but if you look close, they all have common factors, and that would really reduce the amount of things I'm having to write on my list. Does that make sense? Do that. Oh, and if there's a negative in front, one more thing. What do you do if there's a negative in front? We ever worked on with a negative in front? Factor it out. So there's a negative in front. Negative 4 goes into all of these. So I would get 6x squared plus 5x minus 6. And that's much more manageable, and there's not a weird negative in front. So if you ever see that, I don't even know if there are any like that on your worksheet, but just future reference, if you ever have a negative in front.